Okay, well, here's the graph. Okay, here's -2, here's 2. It should be clear that here's -1, 0, 1, and 2. Okay. And it's also clear that y is 1 here, y is 2, y is 4 here. Now we have to do the point 2, 1. We can do that with what we've got already. And I was going to do this in a different color. I've got these circled in green. 2, 1 is right here. Okay. Well, what's the next easiest point? I think 1, 0 is probably pretty easy, right? You know where 1, 0 is? Can you look at this graph and tell me where 1, 0 is? Okay. If not, you need to look at more graphs. You need to be able to read them. But if you're in my class, you're going to have plenty of opportunity to practice that. 1, 0 is here. X is 1, y is 0. Okay. Now, what about 1/2 -1? X has to be 1/2. Okay. Do we have a line for x equals 1/2? No, we got a line for x equals 0 and x equals 1. X equals 1/2 is here. Halfway between 0 and 1, just like 1/2 is halfway between 0 and 1 here. Okay, so here's the line. X equals 1/2. And where's the line for y equals -1? Well, if the line for y equals 1 is here, the line for y equals -1 has to be below the axis, the same distance. So this would approximate the line y equals -1, and we got a point here. And what about x equals 1/4? Well, 1/4 is half of a half. So we have to cut this in half. And if you're in my class, you're starting to understand why we cut the square the way we did. You think about it. Okay, so this line would be x equals 1/4. And that goes with y equals -2. Okay, then we have the point 4, 2. Means x has to be 4. Where's x equals 4? Well, here's 1, here's 2. So here's 3, and here's 4. I got it a little too far that way, but it's okay. Right? And we want the point 4, 2. So x is 4, y is 2. Going to be like here, and now we can draw the curve. And right here is our function and our inverse function. Well, now I want to show you how to do this with a little algebra. You don't know the algebra that goes with this function, okay? And you won't for at least another month. Okay, maybe as much as 6 weeks before we get to that. This function has a name. It's the base 2 log function. And when we get to log and exponential functions, it's really easier than what comes before, okay? So that's something you almost look forward to. Let's take the function y equals 2x minus 3. Now write that down again, but replace y with x and replace x with y. In other words, you're switching x and y. Yeah, now can you solve that equation for y? Can you solve for y now? Oh, wait a minute, whoa. This is y, right? You're replacing y with x. You replace y with 2x. You got to put y where x was and don't carry anything else, right? Simply replace x with y and replace y with x. See, that's what you get for thinking. Okay. Now, I think I was recording when I said we want to take this equation, replace x with y and replace y with x. And that's very simple. Here's a y, we're going to make it x. Here's an x, we're going to make that y. Okay, so we switch x and y, and now we solve this equation for y. We're going to have to do a little algebra. Okay. Nobody solved this correctly. And you really need to review solving linear equations. And I'll give you a note and a reference on that. Okay, so we solve for y. Okay, so again, we start with x equals 2y minus 3. We want to isolate y. Now, okay, you want to do plus 3 and plus 3 on both sides, okay? Then you might even want to line up this plus 3 with this minus 3 because you want to isolate y, okay? So when we do this, what do you get on the left-hand side? I'm going to tell you, I'd advise you not to write them out like this because it creates massive confusion, okay? What we want to do is we'll want to add 3 to both sides. We'll do that with x plus 3 equals 2y minus 3 plus 3. Okay? So we just attach a plus 3 on both sides. Now, people were writing x and a 3 here and getting a 3x. That's fundamentally, you can't solve linear equations that way, okay? So I want to see you write it out like this. So you get x plus 3 and not 3x there, because I think at least half the class got a 3x there. Okay, now why do we do that? Because we're trying to isolate y. Negative 3 plus 3 is 0. And that just leaves us with 2y, and we've got x plus 3 over here. Now, how do we solve this? We divide both sides by 2. If we divide 2y by 2, we're going to get y. So we're going to get x plus 3 over 2 equals 2y over 2. Okay? 2y over 2. Now, people draw a line through that. I don't like the line. 2 divided by 2 is 1. 2 is divided by 2 here. Okay? And that leaves you y. And x plus 3 is divided by 2. And we don't draw lines through anything here. Okay? And that's your solution. So y equals x plus 3 over 2. This is your inverse function. I'm going to call this function f of x. Matter of fact, I'm going to emphasize the y here. This is a function. Y equals F inverse of X equals X plus 3 over 2. Okay. Now, still in focus. I'm gonna have to do one more thing, and I'm gonna do it, okay? If I plug this whole expression in for X, if I replace X by this, you might not know why I'm doing this, but I want to do this to just show you a little more algebra. You get Y equals by X plus 3 over 2, 2 times X plus 3 over 2 minus 3. Okay. Now, can we simplify this? Well, yeah. This 2 is divided by this 2 clearly. And I'll actually write it out like this, so that Y equals X plus 3 minus 3, so that Y equals X. This is a big deal about inverse functions. And we're going to try to build on that next time. In the meantime, now let me take a look at what we've got here.